Welcome to Unapologetically Technical. This is a show that's different. We go deep. We go all the way down. We go down those technical rabbit holes that most shows won't go into, and I hope that you appreciate that. With me today is Frances Perry. She's a good friend of mine, and she is the head of engineering at MotherDuck. Welcome to the show, Frances. Would you mind introducing yourself a bit more?
Thanks, Jesse. So I am the head of engineering at MotherDuck, which is a small database data warehouse startup. Been there for about a year. Before that, I spent a long portion of my career at Google, going through all sorts of different parts of the job ladder: developer, tech lead, manager, and playing a bunch in the big data space, which is where I ran into you back working with the Apache Foundation and Beam many years ago.
Yeah, and it's one of those beautiful things about conferences and community that I think that we don't realize is some of the people that I know, the people I'm close to, met in those times. They're Apache Foundation members. It isn't just about technology; it's about a community.
Well, should we explain how this happened? I was meaning to text a father of one of my kids' friends, and I texted the wrong Jesse. And I texted you about like whatever my kid was up to that evening, and I was like, "Oh, wrong Jesse." And it was serendipitous, right? Because we got back into touch after being apart for a few years.
Yeah, it was nice. And because I had been meaning I wanted you on because I knew that you would have this great repertoire of questions that I could ask that with very unique experience. So we're going to get into some unique territory that I haven't been able to get into with other shows, or with other guests, I should say. So you've introduced yourself. You spent a ton of time at Google, but you talked about in your LinkedIn profile about distributed systems, and you talked about distributed people systems, and them being fun. How is that fun?
Oh, so one of the things I think we all learn as we go through our software engineering career is that as fun as technology is, and as complicated as it can be, getting things done at scale really ends up being a people challenge, right? One of the best things about tech is how opinionated and smart, folks are. But then getting those people to work well together turns out to be a whole other challenge. And I think one of the things I've really done in my career is mirror the technology in how I've been thinking about people. So I spent the early parts of my career learning how to scale data and scale services. Now I figure out how to scale people. And it's exactly the same kinds of challenges. So for example, if you think of merge sort versus MapReduce, right? They're both just sorting algorithms. I think of line management or direct management and organizational management as exactly the same. The difference between merge sort and MapReduce is that in merge sort, you're doing the sorting. That's what you're thinking about. In MapReduce, you're getting sorting at the end, but along the way, you're thinking about fault tolerance, latency, error handling, right? How does the master node, you don't use that anymore. How does the controlling node spread things out across, right, all of the different worker nodes? What happens, when things fail? Like that's what I do in organizational management. It's just MapReduce over people, and that's, I think, one of my very favorite things to think about.
Do people get mad when you call them nodes?
The kinds of people I work with are the ones who appreciate that. Right. I think when you see just like anything, when you see the enthusiasm in someone, right? Like you can tell I'm not doing that to insult you. I'm doing that because it's challenging and fun. So
I would tell them that they're my favorite node until they fail.
Until they fail, and then they're just dead. I'll replace them. No. See, that's not how you treat people. That's true. That part is different.
Did you see the thing recently with a company in India that said, okay, they did a survey about who was stressed, and then they fired everybody who was stressed. And I thought, okay, well, maybe they were distributed systems people, and they said, okay, all you stress nodes, we're just going to kill you because you're not going to be fault tolerant now.
that is, let's just be very clear, not the best way to manage.
All right, you heard it here. Not the best way to manage. These pearls of wisdom from Frances. All right. Well, let's get into Google. You spent 16 years there, which is kind of crazy to have spent so much time. I mean, I should back up. I didn't realize you had your PhD for one.
Yeah.
And I always find that interesting about technology is some of the people I've known for a while, I don't realize they have a PhD until I actually look at their profile and they say, oh, well, they have a PhD. Never would have guessed it. Not in
No,
a
I
bad
think
way. It's just that in software engineering, you don't say, no, call me Dr. Perry or something like that.
nope. Nope. And I think also, for some of us who head off into industry, it's actually when I first, the things I learned during that portion of schooling really showed up later. I think in my career, not at first. I showed up at Google and oh gosh, they would make jokes about PhD's code quality. Because like I couldn't code at all, not in a production sense. I remember during my Google interview, I think I must have done a really shaky job on the coding. And they asked me, well, do you have some example code you can share with me? And I didn't, honestly, because I didn't write much code. And so I sent them my formal structural induction proofs over type theory structure and said, here's some structured thinking I've done instead. They still hired me, luckily. But it's a different skill set. Almost a liability at first, I think.
That is, it's good that you have that levity to be able to go back and look at the situation and say, yeah, I didn't have much code, and I'm completely surprised by all this. Personally, I'm self-taught in everything. So as I started dealing with people, bachelor's, master's, PhD, it surprised me how little code, where mine was just 100% code. There's no theory, just you need to learn how to code this. Production code, that's it.
I think one of my favorite things as a manager these days is to find how to unlock the value that people can bring regardless of background. Right. I think, Google was notorious in the early days for, only hiring from Stanford. And that is such a mistake, right? When you limit to someone with a certain set of credentials or a certain background, some of the most powerful folks I know in the industry are self-taught or they come from a humanities background or they bring a different lens. And I think it's when you bring all those lenses together that we build the best software, we make the best products together.
Well, speaking of building the best products, what did you learn in 16 years at Google? Yeah, give just one sentence. We need to reduce that down.
One sentence. I think I would say I learned all the nuance that goes into making good software. And it's not code, going back to our earlier statement. And I think, each phase of my journey, I went from, being a junior developer to leading projects, to dabbling in management, to becoming an engineering director. And in each phase along the way, I learned different pieces. So I can't pinpoint one lesson, but I can sort of highlight, it was about the journey into making software and all the pieces that go into it.
All right. Well, do tell then.
Awesome. So, I joined Google to work on a compiler, right? My PhD was in compilers and type systems and so on. And I didn't expect to go into industry, but they had a compiler. I wanted to work on compilers and I got there, and in typical Google fashion, it was canceled within 2 months. But we pivoted and so shifted to what became Flume. And so Google had a huge amount of logs, right? Just like an insane amount of logs. And so they'd been developing all their own tools to process those logs. And, by this point, it was 2008. So, MapReduce, the paper had been out for 4 years and everything. And everyone knew MapReduce was this great abstraction layer for reasoning about, or for this great tool for doing distributed computations. But what MapReduce struggled with was it was actually too limiting. So it was a very specific structure: map, shuffle, combine, reduce. Those were the sort of the things you could configure. And you could solve a lot of problems with MapReduce if you took your algorithm and you twisted it and you contorted it and you sort of shoved it down into that very big structure, which was great. It was powerful. But then at the end of the day, somebody came along and looked at what you left behind and like, what is this doing? You basically had to take your business logic and and make it hard to read in order to make it efficient at the scale that things were running. So what Flume did was basically up-level, everything in computer science is solved with a level of abstraction, right? So it up-leveled that into these more general data pipelines of how you would transform, join, et cetera, your data. And then Flume's optimizer, I wrote the original version, would sort of condense that into an individual series of MapReduces that were as efficient as possible. And so, along that journey, I think the things I learned were really sort of the basics of data processing, but more importantly, software engineering at scale. You work in school, you take your classes, like it's a really different way to look at to really understand deep in your soul why testing is important, right, at scale, and to understand how to do code reviews and those pieces. So I think that was really my initial foundation as a software engineer. After we wrote Flume, and it was chugging along inside Google, we wrote a paper about it, and it was a good time. Google Cloud was starting up, right? And some of the early ideas from
let me ask you some questions about Flume before you move on.
Absolutely.
So you talked about Flume, and I've asked several Googlers the same question. Why wasn't Flume open sourced instead of just writing a paper?
Oh, that is the history of why wasn't MapReduce open sourced instead of writing a paper, right? I mean, at the time, that is not where the culture was and where the leadership was. I think if you look at where Google is now and how it embraces open source, it's fundamentally different, right? And that shifted maybe in the early 2010s. You start to see Kubernetes and things get open source. But back sort of earlier on, I think it was thought that this was our proprietary ideas. And it wasn't, we didn't put the time into turning them into products. I think we also didn't see the need, right? So it changed. I think also you have to realize how deeply integrated Google's tech stack is. We built everything from scratch. We had our own file system, right? We had our own data management system. Data center, machine management system. We had all of these pieces. And so open sourcing something without the foundation that it was tied to just wasn't going to work without a significant amount of work. And so that just wasn't part of where we were going, right? The papers were an afterthought. We were building things for the business and then writing afterwards, like, hey, look at the cool thing we did, by the way. But we would keep going.
So why did you write the paper then? Was it your academic background that made you want to do that?
I think a lot of the internal infrastructure were ex-academics, right? A lot of folks, the Seattle office at the time was headed by Brian Bershad, who was a UW professor who was there on sabbatical. Craig Chambers, also a UW professor on sabbatical, joined Google, started Flume. So you sort of had this real influx of folks who were sort of on the cutting edge of what these foundational systems could do. So you sort of had the folks who liked the theory, but wanted to be a little more practical. So we still had the academic side in our blood.
Okay. And I want to go back to a thing that we were talking about before we started recording, and that was this difference between practitioners versus creators. And that kind of surfaces what you were just talking about, is these professors wanting to do something non-theoretical, more practical. And I've had this conversation with a few people, and I've written about it, where the people who write our software are not generally the users of that software, and the two are very different. So would you mind talking more about that?
Incredibly different, but I'm going to go forward into the next step into Cloud Dataflow with that, because I think that's when I learned that lesson, right? When I was working on Flume, I thought I had customers. Those were other Google engineers, right? And I listened to them, and I absolutely took feedback. But those customers were still very similar to me as a Google engineer. They worked in the same build system. We had one build system with 3 file formats and 2 approved languages, right? A very, very homogeneous environment. And we were all the kinds of people who wanted to know how the system worked, who wanted all the knobs and dials and so on. But when So when Google Cloud started, and I think this is honestly that distinction you said about the difference between builders and practitioners is the largest reason Google Cloud struggled in the early days, because what we thought, I think in the moment, and I was still a junior engineer, so I can't speak too much to the strategy, but was that we had this cutting edge technology and people would benefit from it. But a lot of the early days of Google Cloud, I think we didn't listen to what people actually wanted. We tried to tell them, sort of with that hubris that engineers sometimes have of, here's a tool that will change your life. But we didn't ask them how they wanted their life to change and how they were going to use it. And I just remember realizing so viscerally that I could design an API, I could design a system and give it to people. And you know what the first thing they do with it? They use it in a way that I didn't expect them to, right? Because they're thinking about things differently and they're seeing it as a tool. And so to me, I think that whole next phase of my career was really learning that lesson that as smart as I might be, as deeply as I know the technology I build, I have to listen to how people are going to use it because it's different than my own experience.
That is interesting. And it's good that you came to those conclusions. I would also add one of the conclusions I came to after being around the cloud era, me being cloud era and being around the Google people, is that that you assume that others were at your level or your level of thinking about the problem, rather than this is 25% of my day job and I don't think about this very much. And this just needs to kind of go along with what I'm already doing.
Turns out people who are using these systems actually are using them to do a job. And that job needs to take up most of their brain space.
Yes.
Right. And I think this is where I was sort of hinting, like, I think some of these big tech places tend to hire the people who really want to understand all the details. And so I was used to users who did. Users who wanted to read the source code for fun because they were those kind of people, right? But that's, again, when it's a tool to get work done, you don't have the time for that, right? You don't actually want to understand the beauty of every individual decision we made inside. We just want it to be usable. And there's actually such a critical gap. And I think as infrastructure builders, we often really, we pride ourselves on the pieces that feel technically difficult. And that's, the bits of performance we've managed to eke out of the system, or the additional bits of scale or something, the things we write academic papers about. But the actual value in the software is making it usable to people, right? And it may not feel as technically complex to ensure that it's a smooth onboarding experience or that customers have the controls they need or something. But without that, it doesn't land. It's not usable and it doesn't work for people. I think that's a lesson that we learned the hard way. And I think you see that when you look back at sort of the early growth of Google Cloud and how it sort of struggled to gain adoption.
I would agree with you. I think that anybody who's creating a new technology, it's half technology and it's half adoption. And a big part of that adoption is how people interface, how your users actually use it. And I'll put this forward, since when you write an API, your API should not be an afterthought. It should be, you should be writing your pseudocode first and then saying, now here's how I'm going to map that. And I'll pick on Spark because I don't think they did that. I think Spark said, here's what we have, here's what you get. But I would really love somebody to say, okay, here is the pseudocode. I want this to be beautiful and to be as understandable as possible. And then I'm going to make it work. What do you think?
Have you ever seen Joshua Block's bumper sticker API design?
No.
It's this gorgeous list. I'm going to see. I started to Google it to pull it up, and I'm not going to do it. I'm going to see how many I can remember off the top of my head. It's a set of sort of tenets that are short and sweet and could be put on a bumper sticker if you were that kind of nerd. But things like public API design, like diamonds, are forever. Right? This idea that when you design an API, you need to think really intentionally about how you change it over time, because your customers have written code against it. And if you go making backwards incompatible changes and things, you are causing significant churn, right, for your users. Or there was another one, when in Rome, do as the Romans do, or something like. When I first wrote, so we wrote FlumeJava. That was the first version of Flume. And then, a lot of Google was still using C++ in the day. So a few months later, I got tasked with writing Flume C++. And many years later, I met someone, he said, yeah, Flume C++ is okay, but it just doesn't feel right. It feels like it was written by a Java developer. I was like, oh dear. Yeah, I wonder who that could have been. But you have to think about the environment and the language that your users speak and make it part of that, right? I think a good API design, it has to be error proof. I'm sure there's a bumper sticker. I forget off the top of my head the one about error handling, right? But you have to prevent users from creating errors, from accidentally shooting themselves in the foot. You have to make it easy to use. And I think there's all of these things when you go to design an API. And that's even before what you were hinting at, right? Which is like, it has to represent the right concepts. The API to a system is how users think about your system and what their mental model is going to be. And it's so critical to get that right.
I'll never forget. I was with you one time and somebody asked you about if they were asking about Beam, if the Beam API was finished or should it be considered production worthy. And you said, well, our API surface isn't 100% set yet, which I don't know. Do you remember that time? And I was telling you for Google parlance, that meant something different than what everybody outside of Google thought.
Yep.
So for what that person heard was, this isn't production ready, don't use this, where you were saying, no, that API has not fully, it's still subject to change.
Yep. And I think, part of the journey in Dataflow for me was really learning and living the idea of semantic versioning, right? Being really crisp to your customers. What is a major backwards incompatible change? What is a minor feature add? What is a patch that should be safe to roll out at any point? Because and again, going back to sort of having to learn about customers as an infrastructure builder inside Google, we had one code base. I could access the entire darn thing. And if I wanted to change an API, I could use a tool that would generate CLs for everyone across the company that called that API to change how they called it. So the idea of backwards compatibility just wasn't the same. Which was it? Was it Guava? One of these Java libraries, it was a diamond dependency problem, right? We sucked in one version of Guava via Hadoop and a different version via something else. And it was just a complete complication that we had to learn how to work around and how to version. It's actually so critical as an API designer. But I think there's another interesting hint in what you said, which is the difference between stable APIs and production readiness, right? And production stability and how you communicate to users where that is. Because I think the scariest thing as a data person is data corruption. Right, data loss, data corruption. And knowing how, whenever you build anything that touches data, you have to be so very careful about that and how to let your customers understand where you are in that journey of protecting their data. We all have the moments in the past where we've really screwed something up and they stick with us forever. There was a change I made in Flume way back in the day where when MapReduce ran, right, and it was running sharded across multiple machines, all of these machines would start generating their output files, but they'd come in different orders. And so you'd look at some point in time while it was running, you'd only have 6 of the 9 output files, or, well, it was more likely you'd have 497 of the 3002, but whatever. And so we used to write all those files to a temp directory. And then once they were all ready, copy them over. So you started the data set appeared atomically, even though it was generated in pieces. And I changed something in the TTL of those temporary directories. And what that meant is that at Google, all Flume jobs processing all of that logs data kept running successfully. And then 3 days after they finished, all the data disappeared. And I just remember that moment when I realized the impact of that bug on my users, right? And honestly, data loss like that is simpler because it's visible and people know and they can be mad. Data corruption is much more subtle and actually scares me a lot more these days.
That is a good story. I'm glad I wasn't one of your users. Well, so speaking of users, to help people kind of understand what FlumeJava was, if they're old enough, that would be like Apache Flume.
No, see, this is name. Okay, so the first problem, everything in computer science is solved with a level of abstraction, and also naming is the hardest problem in computer science. Apache Flume actually had nothing to do with Google Flume, unfortunately. It was just two different systems that dealt with logs, and so we thought log-related puns were a good idea. And so two different groups ended up on the log Flume idea. So yes, Apache Flume, different tool. So Google Flume.
It's similar use case, right?
Similar to logs processing, but I think what we were really doing is building a level to write MapReduces in a much more intuitive way, right? A series of MapReduce pipelines. And so from there, you used to have to, like I said, sort of, you often ended up with, these DAGs of pipelines where you're taking data from over here, transforming it, joining with this data, doing a little more transformation, then joining with that, et cetera. And you ended up with these sort of, DAG-like structures. And so, you would look at that and say, how many MapReduces would it take for me to implement that pipeline? And you could often do things where you optimized two different computations together. So for example, if I had a data set and I wanted to go through and I wanted to lowercase all the words, I wanted to split out all the words, right? And sort of tokenize strings if I'm doing like a simple word count. And then I wanted to go through and I wanted to lowercase all the words. And, then I wanted to go through and I wanted to filter out thes and ofs and things because they weren't interesting to me. I could do that as 3 separate passes through my data, right? But if I have terabytes and terabytes of data, that's obviously really inefficient because I'm paying much more for the act of processing, of streaming the data in, doing the transformation, writing it back to disk or something than I am for the actual computation. So you optimize by merging those 3 computations. So for every string you read off disk, you tokenize, then you lowercase, then you filter, and then you write the result back. So that's just a really simple kind of optimization. And, most of us do those in our heads when we're writing pipelines and things without thinking. But when you get to much more complex data processing pipelines, particularly where, this chunk is written as a library, that's how you can see my hands. This chunk is written by a library that somebody else wrote. I'm going to use that and then add my own processing after it. You can really benefit from an optimizer that looks at the full structure of the pipeline and tries to figure out how to run it as efficiently as possible.
I see. So that probably didn't come about till probably more Spark time frame then.
It was, yeah. I mean, I think we did it. I forget exactly when. I wasn't aware of Spark at the time we were doing it. This was sort of 2007, 2008 when we were working on that. And I think, it was really about making it easier to write those pipelines and get them efficient. Because at that point inside Google, right, we had huge numbers of software engineers writing these pipelines. A lot of data was being processed.
Well, now fast forward into Cloud Dataflow. What did you do for that?
So Cloud Dataflow was saying, hey, this looks like a pretty cool tool. Like we think we can do a lot with it. We think it makes data processing easier. What if, as part of Google Cloud, we made it a product? And so that the trickiest thing with something like that, so when you go back to the abstraction of what Flume does, it gives you a way to specify this is a transformation function, this is a combining function, right? And then it figures out how to optimize those for you. But it's basically taking snippets of the code you wrote and moving, optimizing the structure of that. So when you think about building it as a product, what it does is, you tell it the different functions you want to run and how you'd like them to process your data, and it will do that for you. That means that the service is running your code. And as a service builder, your code scares me because I don't know, I don't trust you, right? So really what we were doing under the hood is spinning up a secure sandboxed environment to run your code and then doing the management and monitoring of that for you in an optimized way.
And so that code that people were writing, and you touched on it, and that was what became Apache Beam. And
so so basically to use Cloud Dataflow, you had to use what was relatively a thick client-side library and a different abstraction for thinking about code. Like to enable the system to have the right knowledge of your code, the system to optimize it well had to know things like, is this a one-to-one mapping? Is this a one-to-many mapping? Does this combine and reduce, if you're taking in keys and collections of values, does this reduce the number of values or not? These are the kinds of things, or if this transforms the data, does it increase the data size or decrease the data size? These are the kinds of signals that let the system optimize well, which meant we had to teach people an abstraction layer that gave us those signals. So the FlumeJava API or the Beam API has this notion of P collections, which unlike a simple Java collection is a collection that can be processed in parallel, right? And you write do functions that do something to a single element of that collection. And therefore, if you've got a large collection and you're processing individual elements, you don't care how the system sort of shards stuff out across different machines. But what that meant was to use Dataflow, you had to write a decent amount of code against an API that nobody else had. And going back to your early questions of, why didn't Google open source and so on? When we looked at what that meant for customers, it was actually to use our system, you had to write a lot of code, and that code didn't do you any good anywhere else. And so the immediate concern from customers was vendor lock-in. Right? Or why would I come try out this tool, do all this work, and then if it's not going to work for me, I have to let that, that work is useless. So what we realized is that the API and the way of writing pipelines was useful separately than the service we had for executing them. They both added value. They added more together, we hoped, right? If our service did well. But the API itself and the sort of way of reasoning about these data processing pipelines was useful. And at the same time, a number of other systems had come along. So you had Spark at that point, Apache Flink was a streaming system. And so we realized that we could basically open source the Apache or the API that we had for writing pipelines, and then multiple people could implement backends for it. And so that's where we got to Apache Beam. Beam, it was basically the original Dataflow and Flume APIs. They were very, very similar. Open sourced as a way that we suggested, we thought it might be useful for people to write pipelines, and then you could run them in many different places, many different systems.
And that was probably one of the biggest regrets I have, or biggest technology regrets I have, that Beam didn't go further. I wish it would have, because it was the right abstraction. As you look at the other APIs, especially I pick on Apache Spark again, their API abstraction was not right, in my opinion. And when I saw Beam, I saw, okay, yes, this is exactly the way the abstraction should be. Because the key thing that you didn't mention it specifically is you didn't have to say, this is batch, this is streaming.
Yeah.
This should not be what you are thinking about as you're writing this. The operating system, the Cloud Dataflow in this case, or Flink or whatever, should be figuring out how do you do this run batch or real time.
There's a whole other beautiful moment that I did completely skip over, where we realized that the abstractions that you want to use to process data are the same for batch or streaming. Right? It just had to do with sort of the time periods you were running them over, and that way you could write the same logic and run it in your nightly batch job or run it live for your real-time dashboard. Yeah. So
it is unfortunate. Sorry, go ahead.
Well, yes, and right. So I will be very honest. Like once I left that world in maybe 2018 or so, I haven't paid a huge amount of attention to how Beam has done. Right, but I was part of the original PMC. We open sourced. We went into Apache incubation. We graduated. All these things, and it was a really humbling and wonderful journey to realize how open source worked and how Apache really, puts community above code, and how to operate with respect as a corporate employee in an open source environment. So it was a great journey. But I was at a meetup, maybe a month ago, and somebody said, "Oh yeah, then Apache Beam," and I had this moment. I was like, it was just so exciting. When you build something and then you sort of lose track of it, and then you realize people are still out there and using it and still know about it. So I can't speak to if it lived up to its potential, but I think it has grown in an exciting way.
It has grown. It's still the Cloud Dataflow API, but I thought it would be this thing that united all of us, where we'd be saying, well, where do you run your stuff? It would be more like your backend. Do you run your backend as Apache Splink, but you're obviously writing your code in Beam, and you get your choice. And what I realized out of that is that your vendors will not want that. We were talking about lock-in before, and there's a certain amount of, well, I need lock-in. I need that person to have a pretty difficult time rewriting, and that's unfortunate. Yeah,
I know. I mean, personally, and again, like I said, I've not been part of Google's involvement in Beam in many years. So, I think my personal belief these days is your computations need to be easy to move, and as an industry, we should be building those in standard ways. And honestly, the biggest source for where we go, where people go and how easy it is to move is data gravity, and where your data is stored and what format. Although, again, Iceberg and things, that's starting to shift as well. So I think it'll be interesting to see. But I really hope I think we all benefit when we have to encourage people to use our system because of the properties it has, not because it's too much effort to leave.
Well said. So from there, you went into billing, as you were talking about. What made billing interesting?
At first, honestly, it was just different. I think many of us in our careers benefit from change, right? And for many years, when I sort of stayed in the same space at Google with Flume and Dataflow. It was the same technology, but my role shifted. I went from IC or individual contributor to tech lead to management of a small team, right? And I was learning things along the way. But at some point, I feel like as engineers, changing domains teaches us so much when we can reflect on the differences. And so for me, it was time for a change. When I happened to really like the leadership team on billing when I met with them. I think, we all reach a point in our career when the people we work with becomes as important as the technology. So as sad as I was to leave the big data space, it felt like a good moment for me in growth. But I think what I learned two things in cloud billing. And the personal part was that I learned how to be a leader in a way that I couldn't in the data processing space. And that's because I had built the very first version of that system. And that meant I had an emotional attachment to that system that basically made it harder for me to make the hard decisions that we sometimes have to make, right? To cancel a project, to change how something's done. And so for me, just that sort of career moment where I moved from a thing I had built and cared for to something new meant I could look at it with fresh eyes and go, well, why are we doing it that way? Right? Because all software engineering is about, the environment we're in changes so quickly. Like the decisions you made 2 years ago were probably good ones in the moment with the data you had in the environment you were in. But when you look at them today and everything's changed, you have to be able to look back and question them and change them, right? Because that's how things evolve. And so I think for me, moving to a different domain just taught me that in a way that I would have struggled to learn when it was, my baby, the thing I built that I was questioning. And then from a sort of, the other thing I really started to learn about was the business. So Thomas Kurian had just joined Google Cloud when I joined billing. And one of the first things he did was really shift focus to the sales team from what had been a very engineering-led organization. In fact, he sort of canceled all the open engineering headcount, was like, guess what? We're quadrupling the sales team. But billing was really at the forefront of that, because you can't sell unless you have a way to discount, a way to build those relationships with companies. And so I think it meant I got a really front row seat to the shift Google went through to really becoming aware of enterprise sales, enterprise businesses, and what it means to be part of a company. And what it really taught me was it's not enough to have the hearts and minds of the practitioners that you are trying to sell to. You have to actually be able to, you have to give them the tools to enable their management to accept your software. Right? And that might be things that don't feel like they have anything to do with data processing. So you have to worry about compliance and regulations and discounting structures and cost controls. And like, again, none of that feels connected to the technology, but without those things, your practitioners can't convince their management to buy the tool. Right. And so I think that's really what I learned there is understanding how the management of a company thinks about their software.
That's really interesting. I wouldn't have expected billing to be on the front lines, but as you look at billing systems on the other clouds, they're quite convoluted. I haven't looked at Google's in depth, but I could speak Azure and AWS. It is really difficult to figure out. I just had that problem with Azure. I could not figure out what the hell. I don't know.
Yep. And, I think, and the other thing I learned sort of in there is the way you discount drives customer behavior. If you build a discounting structure that is at odds with how you want people to use the product, you're going to pay for it, because people will do really creative things to save money, right? And so you also have to, as a backend infrastructure person, have to make sure the incentives are aligned. If customers, we're playing with this these days, if you want a system where each user creates their own, works independently because it gives you as the backend more ability to parallelize and move things around and schedule, but you discount for, towards fewer users, then you're going to teach customers to bin pack things and hide, multiple users in one, which then makes it harder for you as a system to do the parallelism you want. Right? Because again, your billing incentives are against the sort of principles of your distributed system.
That is interesting. Okay, I would have never guessed that. On your LinkedIn, you talked about that you scale a team from 20 to 80 people. Very few people I've met have done that in that short of time. What did you learn during that period?
I think that's where I came up with the thought in my own head that, management at scale is MapReduce. And the reason is, I don't know if you've managed people, but, you start off with a small team and you learn a lot when you even get your first or second report, right? Because I think a lot of us who might be tech leading projects or something fall into the trap of thinking, well, I already meet with these people once a week. I'll just manage them. How hard could it be? But when you're in charge of someone's career, their compensation, their identity, the power dynamics are subtle but real. And they really change that relationship. And I had 2 reports. And on my first day managing, one report's dog bit the other report's intern. And I was like, I have to deal with that? Oh, right. Completely different set of challenges and things. But so you learn a lot as you start managing, and your team starts scaling up. And I think when I started with that 20 people, I was managing them all. That's a lot. That's a lot of one-on-ones. That's a lot of sort of helping people through their careers. And that keeps scaling. I think I hit 23 sort of at my peak, and that's just miserable. And I remember thinking to myself, I don't think I want to do this management thing. It's exhausting. I had this vision in my head of, continuing to grow and being at 40 people and just, never getting out of meetings, never getting out of email, and being completely miserable. And then along the way, thanks to a really good manager at the time, I realized that it's like MapReduce, right? You shift how you think. You change, you hire people, you grow people into leadership roles, you enable them, and then you build the sort of structure to help them be successful and how they manage teams. You have to learn how to delegate. Like, I think a lot of us, as we become a tech lead and things, struggle with delegation, realizing that someone's going to do something in a way that's different than yours. Try delegating to a manager. Like, you realize how little signal you have about what people are doing. And therefore, you realize how important it is to up-level, to have proactive strategies, to be setting the tone right. The way that, when you move into management of an organization, the changes you don't get to tell people direction. You get to nudge them. You get to play. There was a great talk somebody did that talks about tapping the blimp, right? If the organization is a blimp and you're a manager of a large organization, just get to tap that blimp a little bit. If you try to move it, the whole thing goes off track, right? And so you have to think about the long term and the way you're scaling people. The culture that you're building has to be self-reinforcing. Every manager's job should be to set their organization up so they can go on an unlimited vacation. Right? I've done my job well if I can disappear and the organization keeps doing the right thing.
It's interesting. You use the same analogy, almost the same analogy I do of a ship. Those really big tanker ships, those can't turn. Those can't move. All you can do is push them just gently. It's a gentle, constant nudge. And that's how you do it with management.
Yep.
That would be my suggestion to everybody.
You start thinking really carefully about, incentives, and, we're all human at the end of the day. And so the things are culture of rewards, either with praise or with financial incentives or things. Those are things that most people will head towards. So you have to think really carefully about the culture that you set up, so that it drives the right behaviors. But I think, so this is the point in my career there where I finally admitted the management track was probably the right one for me. I think I was still technically on the software engineering ladder with 80 reports, and somebody just, until I got laughed at and was told, yeah, okay, time to move to management.
Well, your next move, where you fully embraced that, you were now an engineering director, and you did that with the Google Compute Engine team. Why did you make that switch?
Well, I think so. At this point, I very much considered myself a platform builder, both in terms of the technology. I liked being in tools that were sort of connecting things together, right? The middle layer of the stack, and also a platform builder in terms of the people teams. And I wanted to build a more foundational level of technology, something a little closer to the hardware, just to see what that was about. So I moved into Compute Engine. I drove the guest operating systems team, right? And we were basically curating that environment inside the VM. So when you boot up a VM, what do you see inside, right? There's an operating system, but also it has to be configured to work in that distributed environment because it's running in a virtualized container. And so I think it was really fun to get closer to the tech, and also realize, I think, fundamentally how much technology had changed from when I used to work on MapReduce, right? Like MapReduce and Flume, like if you go back to that original MapReduce paper, guess how big the machines were that we were distributing processing across, 2004?
Those would have been, I think they were Xeons. I think I remember that from the paper, because you described they were Xeon.
They had 2 cores, Jesse, 2.
Yes.
Right? 2 gigs of RAM. These were like, and the way we got data done at scale was to harness thousands of them, right? But you go from that to what we're selling now. And like when I was leaving Compute Engine, we were launching the C4 machines, 96 cores and 1.5 terabytes of RAM. And like, you can just go and buy one of those right now. I mean, it's fundamentally a different scale. And so to really sit there and experience, I think, again, going back to this idea of change and evolution, right? The world and technology is so complex that we focus on how things have evolved in our area, and we often forget to look up and realize that smart people in other parts of the industry are doing their own smart people things, right? So like I was off of data processing land and billing, and meanwhile, machines were just different now. They were like, and when you look at how powerful they are and the things we can do with them, like, my assumptions about the world were broken.
Is that why you decided to join MotherDuck? Do you fundamentally believe that we'll still need distributed systems, but we won't be across as many machines? Is that what you believe?
I think I would say there were 3 reasons I joined MotherDuck, right? One of them is the technology. One of them is the idea of learning and how a new environment really helps you learn. And I've been in big tech for a long time. The third was the people. But yes, for the technology, right? If you look at my, I think that the 2 lessons I learned in my Google career that were sort of tenets of MotherDuck were that idea that, big data is sort of a lie. And by that, I mean, when we were at Google, when I was working on Flume and we were thinking about our definition of big data, like what I started to realize in this nagging sense in the back of my head is I built a system that was more powerful than what most people needed. They didn't need to process data at the scale that we could do. They needed it to actually be easy to use. Right. And I think that's really one of the tenets underlying MotherDuck is this idea that we call it small data, a bit tongue in cheek, right? But small data is things up to 10 terabytes. So it's still not tiny, but not the, petabytes and exabytes I think we all envisioned 15 years ago when we talked about big data. Most computation that people run is still over, a terabyte, maybe 10, but like most people have that data stored, they've got it archived, but they process only a tiny fraction of it. So you take that, and then you take the lesson I learned in Compute Engine, which is that machines are fundamentally different, right? And now you start to wonder, well, wait, why are we building, like distributed systems are complex, right? You can do great things with them, but they also add a level of complexity that you will constantly be paying for in terms of monitoring and complexity, and, they're harder to use. So you look at this idea that data sizes maybe aren't as big as we thought, and machines got really, really big. And now you start to wonder, why do we need these heavily distributed systems? There are obviously places where you need them, but what if there's this chunk of use cases that don't need that complexity anymore? Right. And so that's basically one of the sort of the key idea behind MotherDuck and also DuckDB. And so that was a really, I looked back at sort of the lessons I learned and I thought, yeah, that feels right. That feels right to my lived experience, and I'd like to explore it.
So now we're at the part of the show where we're going to start whiteboarding out. So would you mind whiteboarding out what DuckDB is for us?
I mean, let's see. It's a database, right? It's a file format, a way to store data, and then it's the whole database system. It's all the ways that you interact with that. So I think that, let's add a user over here. Everybody loves ducks, right? That's part of and then that's a very bad duck right there using the database, right? But I think what I want to draw here, what makes DuckDB unique as a database system, right, is a few things. It's entirely, it has no external dependencies. And so what that means is I don't know how to do this. Can I highlight? That's good.
You can circle something. So on the bottom, there's the laser pointer if you just want to circle.
Yeah, but I wanted to that's not what I wanted to do. I wanted to pick that up and move it around to show you that it's portable, but it's fine. I don't need to overuse your drawing tool. But the idea is that DuckDB, because it has no external dependencies, can be embedded in a host process. It means you can run it anywhere. And so that's going to enable all sorts of fun use cases that you couldn't do before. The other thing I think about DuckDB as a database system, it is unapologetically single node. I'm quoting Hannes and Mark, I forget which of them, the founders of DuckDB here. They have a very strong belief that you don't need a distributed system. There's a lot you can do with a single in-process database. And so that's where DuckDB's niche is, right? It's not going to scale out across multiple machines. Instead, what they're going to do is make it wickedly fast in a single machine. And so to do that, right, they're still, and honestly, they're database nerds in a way I will never be a database nerd. So it's a columnar vector, I had to look it up, query engine, right? It's basically, they've built technology in the database world that can be really fast and efficient, and still be small and simple. And so what they're looking at is scaling this up within a single machine. And once you do that, it enables all sorts of things that you couldn't do before, right? You can run a really powerful query on your laptop. This laptop right here, lots of duck stickers because ducks, but also I think eight gigabytes. Forget exactly how many cores, but it's a good, powerful machine. And what you realize is that you can run with DuckDB large queries purely locally on your laptop. And by doing it on your laptop, by taking it out of a distributed system in the cloud, you're getting this connection here super fast, right? Because these guys are, you wanted me to draw, Jesse, so I'm going to draw, this is all in the same laptop. There's your keyboard, right? And by operating in the same laptop, right, you don't have those round trips to the internet. And so when you put that processing where you need it, and you make it fast and you make it efficient, there's a category of things that you can do that you can't do otherwise.
It's interesting that you brought up that notion, because I have a metric where I say from a data scientist or a data analyst having a theory to when they can actually validate that, how long is that? And if you have a system like this that you can do a lot of experiments quickly, then you have the ability to pass fail very, very quickly, where, as you were talking about with the distributed systems, if that takes you 10 minutes, you can divide your day by those 10-minute periods. If that takes
you get while you're waiting for things to run, right? And that leaves you caffeinated and frustrated and unproductive. You want that
and forgetting what you did in the first place. And I think that's actually the worst, that context switch of, I don't remember what I did. I now have to remember what I was doing, what I was thinking. And if you get that in the speed of thought, was what Cloudera tried to call it.
So I think, for that use case, it's exactly right. Right. I want to, and it's an analytical query engine. It does joins and transformations and complex long running queries, but it does them so fast with so little overhead, right, that you can iterate with your data. And that, I think, is really valuable. But do you know the saddest thing about this, Jesse? That duck doesn't do data on their own. Data is about collaboration, right? That duck has, watch me draw bad ducks. There are duck friends that aren't in that laptop, right? And so I think one of the pieces that MotherDuck adds on top of DuckDB then is this idea of how to take that power of DuckDB and make it collaborative. Right, and enable some notion of data sharing, collaboration. Because the first thing your data analyst and is going to want to do is they've figured out what their query is. They've done that exploration, right? That's part of using data. But then there's probably turning it in pipeline, sharing the results with others, building the dashboards, like all the things that actually require you to come outside of that laptop again.
So I can see that drawing a duck was not part of your interview.
You definitely not.
Was that part of your, similar to your interview before, of them seeing your production code?
Yeah, they said send me pictures of your drawing. Yeah, so we use a lot of AI tools to generate pictures of ducks. They do a lot better than I do. That's one of the few places I've fully embraced AI in my life is generating duck pictures.
So that brings up an interesting question, that multi-tenancy question. We were saying, okay, we have duck here and we have duck here. How would they share that query? Do you have some sort of system already in place for that?
Yeah, so let me maybe draw for you. Let's see how I think MotherDuck in bad duck pictures, right? So here is our user duck again. There they are, and here is their friend. Oh, the ducks are getting worse as I get sloppier. You get the idea. What MotherDuck does is, let's draw this in 3 layers. So we have a control plane where you basically contact MotherDuck to our control plane. Here's MotherDuck, and you say, I want to run this query. Right? And we say, fantastic. Here's what we're going to do for you. We are going to spin you up your own little copy of DuckDB over here. This is supposed to be a VM or a container or something running your computation. Right? So we're gonna run your a little copy of DuckDB just for you right here, and it's going to contact. It's got your data stored in the back end. And so actually. Okay, I don't know how to change colors after the fact, so we'll change to a different color for our second duck. Our second duck is going to come along in. They're going to say, oh, I want to run a query over the same data. And they're going to get their own little container running their own definition, their own DuckDB instance in the background that's going to be able to read that same data. And so what we're doing is we're really sticking to this idea that DuckDB is single tenant. It's meant to run DuckDB. Everybody gets their own copy of DuckDB. It's so lightweight. We will spin it up for you when you come in, and we'll tear it down when you're done. And we'll charge you just for the time you've got it up and running. But what we've done in MotherDuck in the background is really play with this storage layer over here, because DuckDB, if we go back to the picture I erased, right, thinks it's running locally. It thinks it's running on your laptop, and it's got a local file system to interact with. Turns out when you put it in the cloud, it doesn't have a local file system, right? So what we actually have is a wrapper, a Fuse wrapper that hides distributed cloud storage behind what looks like a local file system. So each of these instances of DuckDB is able to interact with and what is actually shared layered storage. And by layering it.
Sorry, let me define what Fuse is. Fuse means file system and user space. So it's a user space, a Linux kernel user space way of using non-file systems.
Think of it like a wrapper that lets you mock a file system.
Yes.
Looks
mock
like
a file system like GCS or.
Yeah. So we've actually got a tiered EFS S3 thing behind the scenes. But the DuckDB instance thinks it's its happy local POSIX file system.
Yeah. Okay. So that's interesting. I didn't realize that they weren't. So they're not supporting these natively because that would bloat the binary. They're expecting you on the Fuse side to mount your own.
Well, so the reason we're doing our own storage is actually that it lets us. You take the DuckDB file abstraction or the DuckDB storage format and store it as a series of layers and deltas. And when we do it that way, it enables customers to do things like zero copy clone, or I can share data with you, share a snapshot. I can keep editing it and you've seen the old snapshot, right? Or I can sort of control what versions of data I'm sharing with you. Because, one thing we haven't gotten into here is there are limits to DuckDB and using it in this way. DuckDB is not built to be concurrent, to support, for example, multiple writers. And so one of the things you end up doing in MotherDuck is you have to think a little bit and you have to say, this is my job that writes my data. Right? And it's the one that's actually controlling the file locks and controlling, the transactions. And these are my ducks that are just reading the data. Right? And we can give them read-only copies and read-only access to the data. But that's going to enable us to, for example, add, many more ducks to this picture while still using DuckDB as it was designed.
Interesting. And so this MotherDuck here in the middle, this is proprietary. This is open source as well.
This is a proprietary service that we've built that will basically manage your DuckDB instances for you. So DuckDB itself is running. Let me unlock the screen again. DuckDB itself. I don't have an orange. Everything with Duck should be orange. Is right here. Let's see. Is running inside there, and actually on the laptop sometimes, and in the web browsers of the ducks themselves. But what you see in the MD box is basically the control plane around that. So you come in, you say, hey, I want to run a query. And we say, fantastic. We should, spin you up a container on our Kubernetes cluster, give it this much RAM, give it, this much disk, and then do all of that for you. Because if you think about the value to a customer, right? I just told you C4 VMs are huge. You could, as Jesse, go off, buy yourself C4 VM and run DuckDB on it. What do you need a distributed service? What do you need MotherDuck for? Right? You don't actually, from that sense. You could get, but what you would pay for then is the entire VM. Right. So what we're going to help you with is basically the provisioning, the right sizing of the resources that you need, and tearing them down when you're done. So we'll do the resource management for you.
Okay. Okay. And so that makes sense. So we have our DuckDB process that gets spun up, reads the data, returns our results to our happy ducks.
Yep.
And where is the table definitions? Are they here in this metadata or MotherDuck as well?
I mean, we store some metadata there as well. Yes. The other thing to point out, which let's see how I can draw this. Oh goodness. This duck on their laptop. Again, I did not get a PhD in drawing. Is running an instance of DuckDB. That instance of DuckDB is coordinating with this same duck's instance right here. Right. And so one of the things that MotherDuck does is basically DuckDB is built to be extensible, right? So the copy of DuckDB that's running here has a little MotherDuck extension right there. And so we're able to augment the query planning phase of DuckDB. So when it gets the query, right? It's figuring out how to execute it. It's got the abstract syntax tree. And we're able to figure out where the data processing should happen. So if you, for example, have a local file, you've got some local file here that you're processing and you're trying to join it to data in the cloud, right? You could upload that file to the cloud and do the processing on the cloud node, or you could download parts of the data from the cloud to your local laptop and do the processing there. And the way you do that depends purely on the mechanics of what kinds of processing you're doing, where the data sizes are the smallest and things. But if we can, you go back to your interactive user, right, who's trying to explore data live, chances are they're running versions of the same query over the same data time and time again, right? So what we'll do is actually start caching some of this data from over here and move it to your laptop. And so you're able to do the processing locally while you're iterating.
At that point, you are kind of becoming a distributed system. You're moving results like that.
Picking at hairs. Yeah. So we'll call it vertical, not horizontal, right? It won't scale more than this. Right? We're not going to it's not going to grow out hugely horizontal, but it is going to do smart things about data locality. Yes. Right. And it is going to do smart things about sharing. And there's, we have many nodes. So yes, we are technically a distributed system, but we're not scaling horizontally in the same way. We call it vertical.
Yeah, I can understand that. But one day when you do it, I'm going to say, I told you so.
You hold that in your back pocket, Jesse. I mean, I think, it's a different way of scaling. And I think some of the things we're so excited about is if you take this idea of hybrid execution, right, where we renamed it, plus our marketing folks, we call it dual execution now, of dual execution, where you've got this version of DuckDB on the local browser talking to one in the cloud. You can make that connection work across any system. So we've been partnering with a few other companies, Hydra and things, to release what's called PG DuckDB, which actually runs DuckDB inside your Postgres server. And that way, it'll actually enable you to do joint queries, for example, across the data you have in Postgres and data stored somewhere else. And use DuckDB to do those analytical queries, because Postgres isn't great at analytical, right? And so you add in these other kinds of technologies, and you can run the portions of processing where the data is actually located.
One thing I want to go back to, and what makes DuckDB so fast? You kind of alluded to it before, but what is that fundamental change or mindset thing, or is it just the fact that it isn't distributed that's making it so fast?
I think, and this is where you will hit up against the bounds of my knowledge I am not a database builder in the way that Hannes, Mark, and some of our team is. But I think it's this belief that simplicity and single process embedded processing will get us really far. And that combined with the columnized vector query engine and the deep-seated, like they're going to wring as much performance out of that single node as they can. And they're the experts at that, right? Right, not me. But you do that, and then you think about how to scale those nodes, and you really have a different fundamental technology and a fundamental different architecture at the root. I said I joined MotherDuck for change, and one of the things I'm learning is how to do a startup. Right? What does it mean to work at a startup? And one of the earliest lessons for me was to be a startup, you need a different way of looking at the world. You need to think you have a way to do things differently than the folks before you. Because with a small amount of money and a small number of people, you can't, take on the existing large companies. They've got many more resources than you. So you need something different. And for us, it's this idea that vertical scaling and avoiding the complexity of a broad distributed system will get us somewhere.
It will. It definitely will. I have talked about a bit on this show. Distributed systems are difficult, no matter what a particular vendor will tell you. Distributed systems don't make something easy; they make something far more difficult. And it's kind of what you were just talking about. Kind of clicked in my brain. Or if you and I were talking about this in terms of, let's say, Cloud Dataflow, and we're saying, "Oh, we have a problem," we'd be thinking about, okay, now how do we pawn that off on, and how do we scale that horizontally? Where if you're on a single process, you're having to say, we're going to have to spend our engineering time bringing that out, like we were talking about.
Yeah. Well, I think, another key lesson is really, so one of the first lessons I learned as an API builder is that you don't give your users all the knobs and dials they want. Because if you try to do that, you end up with a system that's so convoluted and hard to use, it doesn't make any sense. Right. So then the lesson many people, myself included, take from that is, I will define the perfect abstraction and give it to the customers, and they shall never see what is behind the curtain, and I will do everything perfectly for them. And then you realize that's actually really hard. And so it's that balance of giving users the control they need and the visibility they need to integrate your tool into the rest of their workflow, but no more than that. Right? Because I think sometimes when we think about making things simple, we actually go too far and we take away your ability, and we forget that, the people using our system, again, to your point earlier, are not using our system for the fun of it because they love the system. They're using our system to get a job done. And they've got their own operational environment that they are working within, and they need the tools to integrate and monitor, your product in that environment.
So let's say I'm sitting here thinking, all this MotherDuck stuff is great, but I want to run it myself. What suggestions would you give them for running it themselves?
Well, so I think that the question, honestly, there is a number of use cases where DuckDB will work great for you. And you don't need MotherDuck to take some of the pieces for you, right? And I think that's fine. But I think that, what MotherDuck does is really build you sort of a basic data warehouse system on top of DuckDB, where you will take some of the lifting for you. We'll take the we'll help you with the sharing and the collaboration. We'll help you with the resource allocation, the right sizing, all that resource management. But like all tools, right, you still have to, what we want to give you, I think, is the right ways to integrate into your environment, the right set of controls. So going back to like lessons from billing, right? Those C4 VMs and the amount of resources you can use with a tool like this is really high. Does mean that if you put it into somebody's hands, they can run up a bill, right? So what an organization wants to know is, how do I let Jesse run all the processing he wants, but Frances only, I don't expect her to be running up processing, and I want to put bounds around what she can do, so she doesn't run up a huge bill. Like, well, that's honestly one of the scariest things about cloud for folks is I wake up in the morning to a giant bill and I don't know how I got it. So I
It's
think,
scary.
right. And so I think there's a helping people put that in context into their organization and take some of that load for them.
Well, part of what perhaps people don't realize is if they're worried about, hey, is MotherDuck going to make this part not open source or not work very well? That isn't what you worry about. There's a lot of use cases that you rightly point out of small teams, single people. They can just run this on their laptop. They could run it themselves. It's when you're at a bigger organization that's when you need this whole thing. And
It's funny, I think
this orchestration.
we're looking at, I think, folks who are companies that are at the scale where they are starting to build their first data team, right? And that data team needs a system to collaborate on top of. And not to get, there's always, if you're an individual user, we add some other things. We have a really fun web UI. Here's the nasty secret of me. I work on a database and I still can't write SQL. Not well, but MotherDuck has a nice little AI fix-it bot that helps suggest how Frances should actually format her SQL, or actually write her SQL queries. And I actually get pretty far with that, right? So there's other tools and things we add, but I think that the things that are really valuable is that sort of growing organizational complexity. Right, because we've all seen what happens when you start with one person working on their favorite tool, and then they add the permissions to a few more people, and then you can quickly outgrow those tools, and you end up with more complexity in how you're trying to share, how you're trying to control access and things.
Yeah, that becomes a pain that you don't want that to be part of your job. I mean, lock down things. It's far better to have some other system do that for you.
Yep.
So that's an interesting observation you were talking about just now of not really creating databases, but not really dealing with SQL. What do you think that is? You just never had to write SQL before?
I mean, I think, so in my early days, I wrote tons of FlumeJava, right? I wrote tons of batch and streaming pipelines. But I actually, we talked for many years about adding a SQL interface to Dataflow. I don't know if they've gotten to it. But like all languages and all tools, that's also a great lesson is you can do the Stack Overflow version of using a tool, but until you spend the time to really understand how the tool is meant to be used, you're not writing it as effectively and efficiently as possible. And I just haven't done enough SQL to really feel that I can think in SQL. It's like learning a human language. At some point, if you're bilingual, you can start, thinking in the other language. And I'm not there yet for SQL. And honestly, part of what I accepted about myself as I shifted into management is as much as I enjoy writing code and thinking in that way, and that it drives you to, there's always going to be people problems that I'm going to go chase, right? I always think, I'm going to sit down and write some code this week, and somebody is acting in a different, there's other things I can do to add value to an organization. Writing the SQL is not the place where I'm uniquely qualified.
Well, speaking of coding and writing SQL, do you support UDFs, user-defined functions?
We don't right now. And it comes down to the security model and if you think about what, a UDF will have to be sandboxed if it's untrusted code, right? And we haven't gotten to that. I think one of the biggest lessons, not that we won't, not that it wouldn't be a great feature, but I think one of the biggest lessons I learned moving from big tech to a startup is the hardest part in a startup is looking at all the things you want and sequencing them, right? Like when I was in, one of the things I learned deeply in my bones at Google was reliability and the importance of it. And I got here, and I mean, this was, a year ago, and I looked around and I thought, this is just kind of a mess. Like, I mean, at the time we were pre-GA, we didn't have many customers, et cetera, but it was like, this isn't right. And that was fair. But at the same time, that's not where we were in our evolution as a company. If we built a reliable product that nobody wanted to use, we'd be dead in the water as a startup, right? You've got to find the product market fit first, right? And then you can get to the reliability. And it's, so I think to me, when you go to things like UDFs and stuff like, oh gosh, if I had an army of folks and we had tons more time, we'd be there. But we don't yet.
Well, if there's anybody that's going to be able to create that army, it's going to be you.
Well, but I mean, that to me that's the lesson, right? When I knew how to work within the Google system, but it was a very well-structured system that had been built up over years with specific processes and ways of working and things. And I didn't really know why, because I wasn't there to see why. Right. And so the way of the act of building a company, of deciding that the ways you shape the way we work now will fundamentally change the culture of who we are as a company as we grow. And for me, that's the really exciting part. And I want to build a company that would have supported me as a junior engineer. I want to build a company that will empower our engineers to do their best and to understand their customers and to deliver value.
So that's an interesting observation. I've done that. I've set out to do that in my career as well. As I went up, I didn't get much support, and as I started speaking at conferences, there were only a few people that supported me, and and I look back on it, and as I try to improve that, I think, why didn't? Is it something that we're Gen X and we think differently, or because the boomers definitely didn't do it, and I don't see it much in the millennials? Is this a Gen X thing?
I don't know about the generations, but I think to me, when I think our own pasts color our futures and who we are. And I know that when I feel supported and empowered, I deliver my best work. And that's the environment I want to build. I think, tech is a place that has had its stereotypes for a very long time, right? You've got your Birkenstock, sock and sandal, bearded developers, and back in the Linux days and things. And one of the things that is so important is to make sure that everyone can contribute. And I think, we do a lot of gatekeeping, perhaps accidentally, by making assumptions about what makes a good engineer. And I think when we can loosen those, we actually realize I'm not allowed to swear. I saw you bleep out Holden. There's a boatload of people out there who can add significant value if only we'd let them in to our culture and our companies and our industry. And I think that's, I feel like I'm a bit, I ended up here accidentally due to a few people at really critical points in my career who believed in me and who encouraged me to keep going and not leave this industry. And I want to systematize that so we don't drive, we welcome people into tech and into data and into this industry.
I applaud that. Thinking about the roadmap, what's most exciting to you about the roadmap, DuckDB?
I think, DuckDB, if you look at some of the benchmarking or things, you can see how quickly DuckDB is improving in terms of performance, in terms of bug fixes. Like, you have to remember, I think DuckDB started in 2018, but they only hit 1.0 in June. And for a database, like, databases take a long time to build. Like, they're really complicated. And so if you look at how quickly DuckDB is maturing, and how much performance is improving and how much the community is growing, I think that act of They are on that wonderful phase of the journey where they're going from an academic idea to industry software. And that to me is the exciting part. I'm sure there's some amazing database innovations they're doing as well. But again, that's not what's in my heart, and that's not the chunk I follow. But I think that act of maturing a software to a place where people can use it for real value. Not just the hobbyists, not the people, like there's always the engineers who are willing to tie themselves into knots to make something work. Right. But it's really moving beyond that, so that the people who only have a little bit of their brain space for your tool because they have another job to do can get value out of it.
I like that. I like that. There was a post I wrote called "We Live, Eat, and Breathe This Stuff," and in that I try to make that same point. You and I, we'll sit and we'll have an unapologetically technical conversation about this, but not everybody cares to do that, has the time to do that, has the headspace to do that. Their kids are screaming. They've got to go mow the lawn. They've got to go do every other thing rather than go deep on this. And so that's a great way of going about that.
I think we often, as an industry, will underestimate the importance of that because it's complex in a different way. Listening to users, helping users see things simply. It's not technically complex, but it's people complex, right? It's actually about simplifying rather than adding complexity. And one of the biggest mistakes engineers make is we think adding complexity makes us smart. But really removing the need for complexity is harder, and that's what we should focus on.
Love that. Remove that need for complexity. Good. Well, so we you kind of touched on it, or you alluded to. How can we make computer science better for women?
I'm going to push back on that question a little bit because I think that the framing that people are complex, right? And I think part of it is, with the industry went through making computer science welcoming to people of different backgrounds. I think to me is the way I frame it. I think, you often see people measuring like how many women in tech and stuff. And that's an easy one because like we all know what the baseline is in society there on, genders. But I think if we over focus on it, then we miss the deeper point, which is it's really about recognizing how to help everyone add value and not pigeonhole ourselves into what we think an engineer looks like. Right. And I think the industry's come a long way in part of that, which is really bringing this idea of unconscious bias and things like, look, you're biased, I'm biased. It's how human brains work. We make assumptions about people based on that first glance, right? But realizing that as an industry, like we can look beyond that, we can think a little more deeply about what people can bring. And also, and this is, I think, the one that's the hardest for us as engineers is recognizing that people have different experiences than we do. Right? Engineers often like to die on hills, right? I will pick a point and I will argue it till I'm blue in the face. But when you think about inclusion and building, like do that for technical things, sure. Like that's fine. That's part of being an engineer. But when it comes to valuing people and their experiences, you don't get to say, well, that's not how I saw it. Like other people's experiences are valid and people see things differently. And so I think one of the ways, as a woman in tech, I feel like I look at what can I do to make this industry more welcoming, right? I've had plenty of my own moments where people thought I didn't belong, and I had to prove myself, more than I should have. And to me, I started in my career doing a lot of mentoring, doing a lot of one-on-one sort of building people up and things. And I realized quickly, again, it's about scale, right? I can't meet with every person in this industry. That's not going to work. So I started to think about what would really have the biggest change. And to me, that's where management ties in, right? Management and leadership sets the tone of the culture and sets what's accepted and what's not. And so I really started to do a lot of mentorship of other managers and to try to get them to build their teams in a way that are truly inclusive in the core, right? And are not making assumptions about who's an engineer or what background an engineer has to have, or I think as an industry we've stopped believing that people have to code in their free time, maybe, right? But like there are many things we can do that accidentally end up making people feel unwelcome.
Do you mind sharing a concrete example or a specific example that doesn't make that person feel too bad?
Well, I mean, there have been. There was a I was a co-author on. Well, so here's the thing. Here's the thing about microaggressions, right? Which are those little cuts that add up to big impact when you're an underrepresented person in an assignment. If you look at any single one of them, they could be an honest mistake. But when you look at the rate at which they occur, it has a huge impact, right? So like, it's the times when I walk into an interview and somebody assumed I was in HR or I was in recruiting, not there to do their technical screen, right? Or I've been at, I've worn my tech swag to events, stood next to my husband, and someone has said to him, "Oh, do you work at company?" And I'm like, I have the jacket on. I work at company, right? I work in tech. And it's just those little pieces where, I feel like it surprises people that I'm here sometimes, right? And that adds up. And I think it's the way they're so subtle and they build. And it's the yeah.
You have kids. You talked about your kids. I talked my kids. I've tried to always think about this in terms of I have two daughters. How are we going to create a place where my two daughters can follow my footsteps? And that's that inclusion that's really important, is creating a place where everybody can contribute in some fashion.
And I think that's actually a wonderful example of that first step, right? Because I don't want to dismiss that statement. I 100% hear you. And I think, when you have a connection with someone and you realize that the world maybe doesn't welcome them, it really hits you hard. But at the same time, like, it shouldn't take a man having a daughter to realize this, right? So that's where I want us to go broader as an industry, right? And what you realize is we all have to go deeper than realizing, like, other people have experiences and those matter and they need to listen to them, right? If they're telling me that there are systemic ways that they don't feel welcome, even if I haven't experienced them myself, like, we have to listen to those and just understand that sometimes I won't understand why this makes them feel not welcome, but it doesn't make their experience any less valid. But I do agree with you, right? Like, we have we experience the world through the people we care about, and my older one's LGBTQ, right, and trans, and it's taught me a lot of things about how we interact with people, seeing it through their eyes. But I think the important thing again is that we make this a systemic change. I don't have to experience it through someone I know and care about to realize that it happens. I think there's just so much, as engineers, we don't always think about other people first. Our minds are analytical. That's the way we go. We want to understand things, right? We're used to thinking from first principles, and sometimes you have to understand that for people, you'll never get to the first principles. I will never understand your lived experiences, and it's okay. I still have to acknowledge you as a human.
So changing it slightly, what do you think we need to do differently for software engineering management?
I think rooting in a culture, rooting in empathy goes a long way. I think a lot of things that go wrong in an organization or a growing team or any group of humans come back to not taking a moment to think about the other person's perspective. I think a lot of so what I hope for engineering management, right, is we can think of it as empowering teams. Like one thing I really appreciated at Google, right, is they were very clear that management is not a promotion. It's a lateral move. Managing people is a different role and a different responsibility. But it doesn't mean, you have more power, you have different power. But, thinking about how to use that power to empower people to do their best. Like, I think at the root, engineering management works well when I give you, as my team, the context so that you can make you can make your own decisions and you can do them well. My job is to provide you the signals about the environment so that you can make the right decisions in the moment, right? Not to try to control the decisions that you make.
That's kind of funny coming from a distributed systems person saying, I'm not going to control you.
Well,
delegate.
But I think it's fault tolerance, right? It's the fact that I might disappear. I can't put myself in as a bottleneck. I have to build a system that keeps going, right? I have to build an organization that can sustain its own momentum, and people who can step up.
Well, Francis, I really appreciate it. You shared so openly. I've loved your perspective, very, very unique perspective on so many different things. So thank you so much for coming on.
Really fun to chat with you, Jesse. Thanks for having me.